Okay, hey guys, Mrs. Johnson here. Today we are going to talk about the real number system. So just so you know, every number that we will ever use this year are real numbers. It's just what they're called. Now there is such thing as an imaginary number, and we can talk about that later for fun. That's not something you really have to not something you really have to know about until you get into high school and higher levels of math. So with that said, I'm going to show you notes for today. Okay, so here we've got our math notebook. Flip it around so you can actually see it and it's not upside down on your screen. I don't have a cool little Promethean board like Mr. Moore, so I'm just using my document camera and making my notes that way. Okay, so I've got my math notebook. I didn't show you guys this the other day, but I kind of wanted to show you the next step of what I do also when I'm taking notes. So I said this first page is for your table of contents. You'll start to notice I've got things written in here. Now I didn't have them the other day. So the first thing I want you guys to know is our first unit is actually unit number 1, the real number system. So that's going to be our first unit. And so at the top of the next page where we have our essential standard number 1, where we're talking about rational versus irrational, we were really just focusing on vocab. At the top of that page, I'm just going to title unit number 1. I meant to do this already and I didn't, so I wanted to share that with you. The real number system. Okay, so that's, and then down here you'll notice I put a page number 1 there so I can kind of keep my pages in order. So I just, essential standard number 1, focusing on vocab, page 1. Then Mr. Moore gave you guys some additional notes on irrational numbers, his non-numbers. So his non-repeating and non-terminating decimals. He has an example. Moving on to the difference between perfect squares and non-perfect squares. That's something you're going to definitely need to know later. But I put that is on page 2, and I just added that to my table of contents. Today, we're going to talk about the real number system, and in specifics, we're going to talk about classifying numbers in the real number system. So that's going to be page number 3. The real number, that's an N, system. I'm just going to abbreviate that because that's a long word. Hopefully you guys know that that goes with that up there. That's going to start on page 3. So I'm going to go to page 3. And then I'm going to do one more thing. I'm going to flip my notebook on its side. Now you'll notice as I was going through this also, I only use the fronts of my pages because if you look, I can kind of see what's going on a little bit on the other side because I use these heavier duty markers. And so I don't want them to bleed and get confusing between the two pages. So I only use the fronts of my pages. You can use fronts, backs, whatever side you want, however you want to do that. But I'm going to label this as the real number system. And underneath that, I'm going to just add the word classifications. Okay. So you're going to see, like I said, I told you the other day, I like to use colors. I got new colors. I've got all the colors, so you'll get to see lots of colors today. Let's say this entire page represents the real number system. So every kind of number that we can break into this, that's the real number system. Now, as you've seen, we have 2 types of real numbers. We have irrational numbers, and they are all part of our real system. And we have rational numbers. Now remember, irrational are our non-numbers. So our non-repeating, non-terminating, non non-perfect squares. So some examples of irrational numbers. 3.786211182 continued. Remember that little ellipsis right there, those three dots means that just goes on continuing. And since we don't have a pattern established, it doesn't have a pattern, it doesn't repeat, okay? So that would be an example of a irrational number. It is non-repeating and non-terminating. It has to meet both requirements. Another example, when we get to our non-perfect squares, the square root of 30. There is no number that when we multiply it by itself, no whole number that when we multiply it by itself will get us to 30. The square root of 30 is going to be between 5 squared and 6 squared, because the 5 squared is 25, 6 squared is 36, 30 is between 25 and 36. So that would be an example. There's also this really, really famous irrational number that you guys have spent a lot of time with. It never repeats, never terminates. It goes on forever and ever and ever. As a matter of fact, people hold contests about how many digits they can memorize. And that would be pi. So those are some examples. Obviously, there are infinite examples because we have so many numbers around this. They could also be negative. The negative sign actually has nothing to do with whether it's rational or irrational. I could say 652.81 2813 ... Even though that kind of appears to have a pattern, it's not a repeating pattern where it's doing the same thing each time. So if it said 812, 812, 812, we could predict the next three digits. But it's because it's 812, 813, we could predict the next one, but we can't know that for sure. So basically, all of these numbers, they can not be written or represented as a fraction. That's your big idea behind an irrational number, okay? Moving on. Now, within the rational number system, this is any number that can be written as a fraction. And Mr. Moore gave you guys a lot of examples about that the other day. He talked about 1/2. Okay, that is already a fraction. We're good to go. 0.125. That can be written as a fraction. It actually ends up being 1/8. Any number that repeats, and we know it repeats because it has that little repetend bar at the top. I know that's going to repeat. I happen to know that equals 7/9. Those are all examples of rational numbers. It could also be a negative. Negative 3/4. We could have a number in front of it. Negative 75.2. Okay. This one right here would also be considered a terminating decimal. That would also be a terminating decimal. So that's another way we know that those can be written as fractions. Okay. Now, I'm going to give you a few other words because there's a few other ways that we can classify rational numbers. We can actually break it down and get more specific. So within the rational number system, we have different levels of numbers. So I'm actually going to go back to the beginning and start with our smallest. And those are called natural numbers. They're also called counting numbers. And our natural numbers and our counting numbers are the kind of numbers that, remember back in the day when you first started learning to count? 1, 2, 3, 4, and so on and so forth. Those are called natural numbers or counting numbers. And then at some point, you learned about the number 0. So we added the number 0, and we called those whole numbers. Okay. So whole numbers include all of the counting numbers plus 0. So they actually start at 0 and then go 1, 2, 3, 4, da, da, da. So natural numbers are a subset of the whole numbers. They're part of the set, and then we add to it with the number 0. So 0 is the new whole number. And then at some point you learned about the opposites of whole positive numbers, and those would be our integers. And integers are the other side of the zero, so they also include all the natural and whole numbers, so 0, 1, 2, 3, 4, and so on and so forth that way, but they also include our negative. So the opposite of our positive whole numbers, okay? So I can look at any given number and I can figure out what classification it falls into. If it's irrational, it's just irrational, but it is also still a real number. If it's rational, it could be just a rational number. It could be a rational integer. It could be a rational number that's an integer that's also a whole number. It could be a rational number that's also an integer that's also a whole number that's also a natural number. And that is the classification of, or the classifications of our real number system.